I mean,
So a good warm up that we could be doing that kind of ties what we've been doing all week long.
are you guys doing what he's talking about, or are you guys?
All right, here we go. X minus 4 is a factor. What does that mean? X minus 4 is a factor. What does that mean? Most of you did it right from the start. Okay, so we're going to do long division? Okay, I would do synthetic too. So x minus 4 is a factor. What does that mean? That what? Just something goes on the 4. So x equals 4. What does that mean? We've talked about this. What's a 0? What's a 0? If x minus 4 is a factor, what's a 0? 4 is a 0. So right there, that's how much of our answer? It's a third of our answer. Right there, right from the start. Because how many answers should we get, Roz? We should get 3 because it's a cubic function. So we just found one of them. Okay? So now that we have a 0, the zeros go on the outside. Coefficients go on the inside. 2, negative 9, 10, negative 24. Drop. Multiply. Add. Multiply. Add. Multiply. Add. Agree? Okay. So that tells me then now that f of x, whoa, it jumped on me. That tells me now that f of x is equal to x minus 4 times what? Two x squared minus x plus 6. Huh? Okay, so now we got to see if we can factor that orange. Right? What times what gets me 2x squared? 2x and x. What times what gets me 6? 3 and 2? In that order? Okay. Yes? Can I get negative x out of those two? I can. If I do what? Plus 3 minus 2. Is that the factored form of the orange? Why not? Instead of positive 6. So this is not factorable.
So what do you want to do?
I don't know. I want to find the zeros.
So you want to do the quadratic formula?
So we're going to have to do the quadratic formula. Yep. So that's going to be x equals the opposite of b is going to be positive 1 plus or minus the square root of b squared minus 4 times a times c. All over. Do it. Oh, what do we got? 1 minus 48 all over 4. Do I like the square root of negative 47?
No.
What do I like in its place? Simplifying the square root of negative 47. So what is it then? It's I times the square root of 47.
Yeah.
That is the zeros. Yep. So all of the zeros are 4 and 1 plus I times the square root of 47 divided by 4 and 1 minus I times the square root of 47 all divided by 4. And there are our 3 answers. Now, I did notice, just so you guys are aware, I did notice on last week's homework that when we have like 2 sets of, or when there's only 2 answers that are given, like this, some people were putting them in parentheses. I'll just say like 2, 3. Okay? Now, in math, if my answers, my roots, my zeros, my solutions are 2 and 3, then I just write 2 and 3, or 2, 3. If I put them in parentheses, what does that do? Makes it a point. Okay? So don't put those in parentheses. Okay? Right? So I noticed that last week and I forgot to mention it on Wednesday. Okay? So don't put, so like in this one, don't put parentheses around it because that makes it be 2 different. Awesome sauce. Here we go. Here's your topic page, Brooke. Okay? Alright? So today is 3-7. Okay? We'll deal with 3-7 actually, if you want to be technical with it, Brooke. It's 3-7. Day 1. So we'll do 3-7 day 2 tomorrow. Your homework is still due tomorrow. Okay? But no quiz tomorrow, notes tomorrow. Quiz on Monday. Okay? Because I'm not going to be here on Monday, so that's why we're having a quiz on Monday. Easier for myself to hand out a quiz than it is to teach this stuff. Okay? So today, I'm going to back up a slide. I'm going to go back to this one that we just started with. So today, what's going to happen is we're going to have a function. But instead of me giving you this part right here, now I'm just going to say, there's the function, find me the zeros. Okay? That's the difference today. I'm taking away where I give you part of the answer already. Okay? So let's do it. Today's topic centers around what is called the rational zero theorem. And the rational zero theorem works for any polynomial function. What the rational zero theorem says, as you write it down, is that if we have a polynomial function, than every rational zero. And remember, a rational zero. Oops, I shouldn't use red because red's on that side already. Rational zero is so a rational zero is a number that can be written as a fraction. Nope. It's just a general function. And it honestly, Abby, has nothing to do with the rational zero function. It just gets me the a sub 0 and the a sub n. Okay? So what the rational zero function says is it says that all of the rational zeros, all of the possible rational zeros, will all be of the form P over Q, where P is a factor of the constant term. That's that number that comes at the end. Divided by all of the factors of the lead coefficient. So everything else in the middle doesn't matter when you're figuring out what the rational zero is. Now, the reason that we do this, or the reason that we have this particular theorem, is because if I just give you a function, I'm going to fast forward one slide. If I just give you a function like this, don't write this down yet because we're not doing it yet. We got more to do on that last slide. Okay? If I just give you this function, there is an infinite amount of zeros that could be possible, right? And from that infinite amount of pool, I gotta find 3 of them. Okay? The rational zero function tells me what it does is it takes that infinite amount of possible zeros and it narrows it down to a group of 10 or 12 or 15 or 16 or 20 or something like that that we can then pluck from and we can try and find something. Okay. Now, this list that we create are only the possible zeros. It's not all of the zeros. Right? It's just the possible ones. And from that list, then we can decide which ones truly are zero. Okay? So here is a general function. Okay? 2x squared plus something x plus something or minus 15 or whatever. Okay? So what the rational zero theorem says is that I need to find all the factors of 15. Okay. What are the factors of 15? 1, 3, 5, and 15. Are there any more? I can think of 4 more. I'm positive. Or I might be negative. I don't know. Oh. So, right? So we could go plus or minus here. Then what I have to do is I have to take all of the factors of 2. What are the factors of 2? Right? Okay. So now what the rational zero theorem says is that my list of possible zeros is I take all of the red numbers and I divide them by all of the green numbers. So let's take the green numbers one at a time. So I have to take all the red numbers and divide them by 1 and negative 1. Well, that's going to be 1 divided by 1 is 1. 3 divided by 1 is 3. 5 divided by 1 is 5. 15 divided by 1 is 15. Then I've got to divide them all by 2. 1 divided by 2 is 1/2. 3 divided by 2 is 3/2. 5 divided by 2 is 5/2. 15 divided by 2 is 15/2. So we've taken an infinite amount of possible zeros, and now we've narrowed it down to 16. From that 16, 2 of them are going to be zeros. But we've taken it, we've narrowed it down, and now we can figure stuff out with that. Okay? Try 1 on your own. Give me the list of all of the possible zeros for this, or the possible rational zeros of this function. Because I take the factors of the constant term, and I take, it's always the first, as long as it's written in standard form, it's the first number and the last number. Okay? Oh yeah. Oh yeah. Big time. Because otherwise you're doing stuff wrong. Yeah. Yeah. So my possible list I got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Agree with that? That's if I take all the red numbers and I divide them by 1. If I take all the red numbers and I now divide them by 2, I get 1 divided by 2 is 1/2. Yes? 2 divided by 2 is? Already have it. 4 divided by 2 is? Already have it. 8 divided by 2 is? Already have it. So there's my list. Okay? All right, let's put it into work now. Okay? So there is my function. F of x equals x cubed plus 2x squared minus 9x minus 18. That's my function. And that's all I'm given. If it were yesterday, I would have said, here's a 0, here's a factor. Okay? Today, I'm just saying, here's the function. Find me all of the zeros, which is bus stop number 3. Okay? We're still on our bus route. Okay? Except now, the first thing that we have to do is we have to find all the potential rational zeros. Because that's where we're going to start trying numbers in there then. Okay? So what are the potential zeros for this function? Okay? So we only have 1, so we really can go right to our list, yes? Yep. Okay? So plus or minus 1, 2, 3, 6, 9, and 18. So that's our list. Because our lead coefficient was 1, so we were just going to be dividing by 1 anyways. Okay? So there's our list. So we've taken an infinite amount of possible zeros, and we've narrowed it down now to 12. Okay? Step 2 says, now what we're going to do is we need to find one of those zeros. We need to find a singular zero. Okay? How do you want to think? What would you even consider to try to find a zero? We could plug in the numbers. We've already done this today. What? We're going to divide, right? We're going to synthetically divide zeros in. Right? So let's start with 1. My coefficients are 1, 2, -9, and -18. 1, 1, 3, 3, -6, -6, -24. Is 1 a zero? No. Okay. So now the next one you want to try. -1. One, 2, -9, -18. 1, -1, 1, -1, -10, 10, -8. 0, not a zero. Not a zero. Find me one. Find me a zero. Find me a zero. So you said -2, Adriana? 1, 2, -9, -18 gets me 1, -2 is 0, 0 is -9, +18 is 0. Yes? Okay, so that is a zero. Okay. So now that we have a zero, we can factor our polynomial. So, oops, I guess I can't write it again. So my original function was f of x equals x cubed plus 2x squared minus 9x minus 18. Okay? So now, since -3 is a zero, or excuse me, I'm sorry, -2 is a zero, that means then that x plus 2 is a factor. F of x can be written as x plus 2 times what? X squared plus 0x, so we don't have to write it, minus 9. Can x squared minus 9 be factored? For what? That's it? And x plus 3? Can I factor any more? No. Okay. So now if I go back way up to the top here, it said find me all the zeros. I've got it in factored form. What would be next? Find the zeros, right? Solve those. X plus 2 equals 0, so x is going to be negative 2. That was our original one that we found. X minus 3 equals 0, so then x equals 3. X plus 3 equals 0, so then x is going to be negative 3. Now, the nice thing is that we found negative 2 to be our first 0. Okay? And so then we went down this path. If we would have found positive 3 to be our first 0, we would have went down another path, but we would have ended up at the exact same spot. Or if we found negative 3 to be our first 0, we went down another path, but we would have ended up in the same spot. There's more than one way to get from here to Mosinee. There's multiple paths. So our answers then, our 3 zeros, are negative 3, negative 2, and positive 3. Or if you wanted to go negative 2 and plus or minus 3, that's fine too. Okay? You try this. Okay? So first off, we got to start with my list. Right? What are all the possible rational zeros? 1, 2, 3, 6, 9, and 18. Because I take these numbers, these factors, and I divide them by those factors. Since it's a 1, we can just go with the first list. Okay? Did somebody find one out of that list? Scobie. 6. Okay? 1, negative 4, negative 15, and 18. 1, 6, 2, 12, negative 3, negative 18, and 0. Yes. Okay? So 6 is a 0, which means that what is the factor? X minus 6 is the factor. Okay? So f of x can be written as x minus 6 times the quantity x squared plus 2x minus 3. Now, Rob, you had a different 0 to start, right? Okay? You had a different 0 to start, right? Okay? But, and that's fine. That's where these paths are all diverging, but they come back around at the end. Okay? So then this would become two numbers that multiply together to be negative 3 and add to be positive 2 are positive 3 and negative 1. So then I can say that x minus 6 is equal to 0, so x is 6. x plus 3 is equal to 0, so x is equal to negative 3. X minus 1 is equal to 0, so x is equal to positive 1. So the 3 zeros of this function, and I should get 3 zeros, are 6, or negative 3, 1, and 6. Yes, sir. You can, okay? But this is faster because we're not trying, you know what I mean? Because so this one only had 12. Sometimes we'll narrow it down to a list of like 40. You know what I mean? Yeah. So it might not be the easiest to do it that way. That's fine. You'll get to the same spot. No, you shouldn't. No, because you need to multiply together to be 6 and add to be